We tell ourselves that human potential has no ceiling. We're going to cure aging, conquer the natural world, and eventually colonize the stars. But the physical universe has built-in speed limits. Take our ultimate metric for this ambition, the Kardashev scale. Astrophysicists like Carl Sagan extended this framework to quantify how a civilization might eventually harness the total energy output of an entire planet and then a galaxy. Yet modern science paints a very different picture. From the microscopic architecture of our own cells to the farthest edge of the observable cosmos, we are boxed in by invisible, inescapable borders. When an infinitely ambitious species collides with the hard mathematics of reality, something has to give. We either learn to master the limits we are trapped inside, or we face extinction. Let's start at the microscopic level. You might think an ultra-endurance athlete can push their body indefinitely with enough training, but there is a strict, unbreakable metabolic ceiling. This chart shows energy output over time. The horizontal line represents a firm biological wall. A human body can only sustain long-term energy expenditure at 2.5 times its basal metabolic rate, the minimum energy required just to stay alive at rest. You can spike your effort for a short burst, but your physiology forces you right back down. If you try to maintain an effort above that line, your body compensates by pulling energy away from other biological necessities. It literally starves other functions and cannibalizes its own tissue to make up the deficit. That hard physical boundary extends to human lifespan. While medicine and lifestyle improvements have increased average life expectancy, extreme longevity eventually hits a wall where mortality becomes highly selective. Demographic data reveals specific demarcation ages, about 85 years for women and 75 for men. Beyond these thresholds, survival is dictated much less by a healthy lifestyle or willpower and much more by underlying genetic variants. We are biological machines, and we cannot indefinitely hack or outrun the foundational constraints of our own hardware. Zooming out from the human body to the entire human civilization, our progress hits another wall. On the Kardashev scale, we sit at about a type 0.72. We are still millennia away from mastering the energy of our own planet. Our development is currently bottlenecked by the 9 planetary boundaries. These are the critical, interconnected environmental systems, like the nitrogen cycle and stratospheric ozone, required to maintain Earth's ecological stability. This radar chart illustrates those 9 boundaries, with a safe operating space in the center. As you can see, since the Industrial Revolution, we'd have pushed 6 of these 9 sectors, including climate change, freshwater change, and biosphere integrity, far out of the safe zone. At the exact moment we are straining our planetary life support, we are also accelerating toward a technological singularity. Futurists like Ray Kurzweil have mapped how exponential growth in computing power is pushing us toward an inflection point where artificial intelligence surpasses human cognition. The convergence of this rapid technological escalation and our breached ecological boundaries acts as a massive pressure point. Astrobiologists call this kind of barrier a great filter, a probabilistic threshold that could prevent a species from ever leaving its home world, potentially ending human history in its familiar form. The very industrial engines we built to achieve infinite economic growth are the exact mechanisms driving us into this global catastrophe. If we manage to survive ourselves and look to the stars, we run into the signal absolute boundary. This map shows our local group, a cluster of galaxies bound together by gravity. Everything outside of this cluster is subject to the cosmological horizon, a limit dictated by dark energy, the mysterious force causing the expansion of the universe to accelerate. Because the actual fabric of space is stretching, those distant galaxy clusters are receding faster than the speed of light relative to us. Every second, more of them cross the horizon and are pushed beyond our reach forever. The math leaves no room for debate. Humanity is permanently restricted to our local group, which accounts for roughly 100 billionth of a percent of the observable universe. Even if we develop theoretical science fiction propulsion, we are locked inside a tiny, isolated, and expanding bubble of the cosmos. But being confined to this bubble does not make our existence a tragedy. These boundaries are simply the parameters of reality, and recognizing them gives our actions meaning. Trillions of years from now, after distant galaxies have faded from view, beings born in our local group will look out into complete darkness. They will never see the cosmic background radiation, and they will have no way of knowing how the universe began. We exist at an incredibly lucky moment in cosmic history. We get to look up and witness the universe in its grandest, most visible, and most spectacular state. Our immediate task is to respect our biological ceilings and repair our planetary boundaries. If we can do that, we earn the time required to explore the trillion stars that are actually within our reach. Infinity is an illusion, but successfully navigating the reality of our specific pocket of the cosmos is the true test of human potential.